Hi guys, today we're going to learn about the fundamental theorem of calculus. We have that dy dx is equal to 3x squared plus 4x minus 5 with the initial condition that y of 2 is equal to negative 1. We want to find y of 3. So we're going to have two methods. Let's start with method 1. We want to integrate, the equation 3x squared plus 4x minus 5 dx. When we integrate this equation, you can see that this is going to be x cubed plus 2x squared minus 5x plus c. Okay? Now, at this point, we want to find the c to have our equation y and then plug the 3. Okay? So, what we're going to do is we're going to use our initial condition, which is y of 2 is equal to negative 1. So we have that y evaluated at 2 is equal to 2 to the power of 3 plus 2 times 2 to the power of 2 minus 5 times 2 plus c. And we know that this is equal to negative 1 from the initial condition. At this point, we combine all the situation that you have over here, and you have that it's going to be 6 plus c is equal to negative 1. And with this, you can see that c is equal to negative 7. With this being said, I pretty much found my y. My y is going to be equal to x cubed plus 2x squared minus 5x minus 7. But that's not what I want. What I want is y evaluated at 3. So you can plug the 3 into your equation y. So you have 3 cubed plus 2 times 3 squared minus 5 times 3 minus 7. And this will give you that this is 23. Therefore, I have that y of 3 is equal to 23. And this is the first method that we're going to use here. The second method that we have is as good. And please imagine that we have exactly the same question. Okay? But I like it better because we're going to use the fundamental theorem of calculus. Using the fundamental theorem of calculus with the name of the function, what we have is that y is, here you have y, well, but we don't have y. Here you have the derivative of y. So this is y prime. Okay? So what we have is that y prime of x dx is going to be equal to y of something minus the y of another something. So what are those somethings? We want the limits of integration. And you are going to tell me, hey, how in the world I'm going to find them? Well, here's my secret. They gave you something, and you want another something. So the x's that you have are 2 and 3. So those are going to be your limits of integration. What they give you and what you want. Okay? So in this situation, you know that 2 is smaller than 3. So you have that we want the integral from 2 to 3 of y prime of x dx. This, using the fundamental theorem of calculus, that it's here, so you can see it and compare it. We have that it's y of 3 minus y of 2. So over here, you can see that what we want is y of 3. So pretty much like an algebra 1 equation, I want to solve it for this one. So I want to leave this one by itself. So what are you going to do with the y of 2? You're going to move it positive to the other side. So with this being said, you have that y of 3 is going to be equal to the integral from 2 to 3 of y prime of x dx plus y of 2. And stop there and think, what do you have? We do have what's y of 2. We know that y of 2 from your initial condition that it's over here, it's negative 1. In addition, you don't have y prime of x dx, the integral, but we can find it because we found the integral. So you do know that this is equal to the integral of 3x squared plus 4x minus 5. So this is pretty similar to the previous method, as you can see, and you have the y of 2. So you know that this one is going to be the integral that we just found above, so it's going to be x cubed plus 2x squared minus 5x, but this one doesn't have the c because you are going to evaluate from 2 to 3. Okay. Moreover, over here you can put the -1 here because you know that this is -1 from the initial condition. So when you compute this, you know that when I plug the 3 here, here, and here, I have that one is going to be 30. And when I plug the 2 here, here, and here, that's going to be -6 and then -1. Okay, so this gives you exactly the number that we had before, 23. So we have that y of 3 is going to be the same 23 that we found above. Okay, that's for this problem. Okay, so sometimes when we need to use the calculator, what are you going to do? Okay, so sometimes, like in this problem that we have over here, there's no antiderivative, so you need to use method 2 and our graphing calculator. Okay, so over here I gave you that f prime of x is going to be equal to sine of x squared, and I gave you the initial condition that f of 1 is equal to -5. And we want to find f of 2. So over here what you can see is, by fundamental theorem of calculus, we know that the limits of integration are going to be this 2 and the 1 is smaller, so 1 to 2 of f prime of x dx. You do know that this is going to be equal to f of 2 minus f of 1. With this being said, we want to solve it for f of 2, so you know that f of 2 in this situation is going to be equal to, again, integral from 1 to 2 f prime of x dx plus f of 1. Okay, this one we can change f prime of x for the sine of x squared. Okay, so you have that this is equal to the integral from 1 to 2 of sine of x squared dx, and then you have that this value is going to be -5. So you can integrate this, but be my guest and try to integrate using u substitution or one of the methods that we have so far, and you're not going to be able to. So what you need to do is you need to plug it in the calculator. Okay, so I'm going to plug in the calculator, and that number is going to be -5, and that will give you something. Okay, so let's plug the situation in the calculator. So you have, well, I have something there. Okay, so you have that it's going to be menu. Okay, over here you go and look for calculus. After that you're going to look for the integral, and I want to find integral, and then you do the 1, 2 here, and then you write your sine of x squared, and then you have the x here. Okay, so you find your integral, and it will give you that it's 0.494. Okay, so 0.4945 ... right? So when I do this computation, you have this one -5, and you have that it's negative, okay, 4.505, okay, and ... okay, so you know that f of 2 is going to be this value that we have over here. Okay, now here the question is, what if you had been given f of 2 and then asked to find f of 1? Well, the fundamental theorem of calculus that we have over here would not change. The only thing that would change in this situation, it would be that I want f of 1, so for f of 1 I would need to move f of 1 to this side and then the integral to the other side, having something like this, f of 2 minus the integral from 1 to 2 f prime of x dx. Okay, and then pretty much then follow method 2, okay, ... You would do exactly the same situation using method 2. Okay, so for this problem what we have is the graph of f prime. Please note that what you see is the graph of f prime, and it consists on 2 line segments, 1, 2, and a semicircle as shown on the right. They give you that f of -2 is equal to 5, and they want you to find f of 0. So let's start with another piece of paper. Okay, the fundamental theorem of calculus using this tells you that the integral from -2 to 0, because that's what it was given to me and that's what I want, of f prime of x dx is equal to f of 0 minus f of negative 2. Okay? In this situation, for part A, I want this guy. So I'm going to move the f of negative 2 to the other side. So pretty much what I have here is that this is equal to the integral from negative 2 to 0. And let me find an eraser because this one is wrong. Okay, so negative 2 to 0 of f prime of x dx. And then we have that it's plus f of negative 2. Okay? So at this point, you are going to tell me, okay, I'm going to do with this one because that's my initial condition. I know that this is going to be something plus 5. But I don't have an equation. What are we going to do? Well, we have something better. You have the graph. You know that the integral is the area under the curve. If we have an interval, it's going to be the area under the curve and the x-axis from that interval. So this is your negative 2 and this is your 0. So guess what? The area that we are going to compute is this beautiful right triangle. Okay? Can you compute that right triangle? I think so. It's 1/2 base times height. Yes? So you know that this is going to be the beautiful number of 9. So f of 0 is going to be 9. Similarly, speaking about fundamental theorem of calculus, if they are asking for f of 2 and it was given the negative 2, what do you have here? Well, I have by fundamental theorem of calculus, okay, I have that it was given to me the negative 2 and the 2 is what I'm looking for. So I have a pretty similar situation to the previous problem, and here you can compare them. So what are we looking for again? This guy. Okay, so we're going to move this one to the other side. Okay, you see it by fundamental theorem of calculus. So you have that this one is going to be the integral from negative 2 to 2 of f prime of x dx plus f of negative 2. Yes or no? So at this point you are like, well, this one is not the same as this one, right? So that one I need to look for more, from negative 2 to 2. So I'm looking at all this big triangle over here. So could you compute this? Yeah, you know that it's going to be positive because it's above the x-axis. In addition to that, you have two choices. You can either use symmetry, using that this is symmetric with respect to the y-axis, or I'm multiplying this 4 times 2, or you can use the formula base times height and then divided by 2. Okay, either way, you have that that's 8, and then we have plus 5 because your initial condition is not going to change, and you have that this is 13. Okay, so that's pretty much it for B. For C, what do you have? Again, you have a very similar situation because you want to use the fundamental theorem of calculus, and let's put an extra piece of paper here so you can compare the three and how similar they are. You want from negative 2 to 6, and you're going to tell me why I want the negative 2, because that was given to you. Okay, f prime of x dx, and this is going to be equal to f of 6 minus f of negative 2. Again, what are we going to do? We're looking for this guy, so we're going to move, following the same idea, we're going to move the f of negative 2 to the other side, having the integral from negative 2 to 6 f prime of x dx being equal, plus f of negative 2, okay? And then you have that this is going to be equal to what? Well, this one is going to be different. Why is going to be different? Because you are going to look from negative 2 up to 6. So you need to take in account that semicircle that we have here. Now watch out with that semicircle. Why? That semicircle is below the x-axis. Therefore, you are going to have this triangle that we have here. Okay? That it's, what was it? It was 8. Okay? But we're also going to have this one, so it's going to be minus 1/2 pi r squared, which you know that it's negative 2 pi, plus, and then you have this guy, which is 5. So combining like terms here, you know that f of 6 is going to be equal to 13 minus 2 pi. Okay, and that's what we have for part C. Okay, and that's it for part C. For the following example, what you have is the graph of f prime. Okay, so let's label it f prime. Okay, so they want you to use the figure over here and the fact that f of 3 is equal to 5. Okay, so here they want you to find f of 0. So using the same idea, the fundamental theorem of calculus here, fundamental theorem of calculus tells you that the integral from what? 0 to 3 of f prime of x dx is going to be equal to f of 3 minus f of 0. Okay? So since they are asking for the f of 0, I would move the f of 0 to the other side, and this one, okay, and the integral to the other side, having what? You would have f of 3 minus the integral from 0 to 3 of f prime of x dx. Please note that this one is minus because here the limit of integration that I chose is the lower limit of integration. Okay? So with this being said, you have that f of 3, you know that that's 5, but this one is going to be minus. Okay? And it's going to be from 0 to 3. So 0 to 3 is this part. Okay? 0 to 3. So that's going to be 4. So this is going to be 5 minus 4, that's 1. Okay? And that's it for part A. Let's look at part B. The fundamental theorem of calculus tells you that using the 3 and the 7, okay, because that's your initial condition and that's what we're looking for, you have 3, 7, f prime of x dx, we have that it's going to be f of 7 minus f of 3. So in this situation, we're looking for this one, therefore this one is like the ones on the previous problem. Okay? Why? Because they are going to be adding. So you have that it's going to be the integral from 3 to 7 f prime of x dx plus f of 3. With this, what are you looking for? Well, I'm looking for the pretty much the area between 3, okay, and 7, okay? So that area that you have over here, what's going to be that? That's going to be the area that you see here, which is 9. That's not 9, that's negative 9 because it's below the x-axis. So you know that it's going to be negative 9, okay, plus 5, which you know that that's going to be negative 4, okay? And that's pretty much it for this problem. Okay, so the following that we have over here, what's the deal with the following that we have over here? F of 9. F of 9, let's go back to our piece of paper. We have that they gave you 3, we want 9, f prime of x dx, that's going to be equal to f of 9 minus f of 3. Okay, and the one that we're looking for is this one, so pretty much similar as the previous one and the previous ones from the other problem. So you know that this is going to be equal to the integral from 3 to 9 f prime of x dx plus f of 3. With this being said, you know that that is going to be equal to, you need to look for this part and this part. Okay, so pretty much you have the negative 9. Okay, then we have this area that it's 2 plus 2. And then last but not least, what other area we have? We don't have an area, but we have the initial condition, which is plus 5. Therefore, you have that this is going to be equal to negative 2. Okay? So that's what we have. You have that f of 9 is going to be negative 2. Now, if I ask you to sketch the graph of f, what are you going to do? Well, you're going to have, you have a lot of points, right? If you have a table here, let's create a mini table here. What do you have? I have that 0 is 1. Okay, then at 3, I have that it's 5. At 7, I have that it's negative 4. And at 9, I know that that's negative 2. Okay, so I have several points. So I have 1, 2, 3, 4, 5, 6, 7. Okay, so I start with 1, 1, 0, right? Isn't that the one that I have? Where is it? 0, 1, excuse me, 0, 1. I'm here getting crazy. Okay, so then we have 3, and then you have that it's going to be 5. So 1, 2, 3, 4, 5. Okay, so that's your second point. The third point that you have is 7, and then 3, 4. Okay, so we have 7. And last but not least, we have 9, which is going to be around here. Okay, so your graph would look like something like this. Okay, that's a rough sketch, but that's your graph F. Okay, that's what we have so far. For this example, we have a pizza with a temperature of 95 degrees Celsius is put into a 25 degrees Celsius room when T equals 0. The pizza's temperature is decreasing at a rate of R of T is equal to 6e to the power of negative 0.1 T degrees Celsius per minute. Now you need to estimate the pizza's temperature when T equals 5. So what you know from the context of the problem is that the pizza starts with 95 degrees, okay, at T0. So what you know is that they give you an equation for the pizza, okay, and it's decreasing at that rate, okay. So the temperature, okay, at T equals 5, okay, of the pizza, okay, what's going to be the deal here? That's going to be equal to the 95 minus some kind of number, and that number is given by the decreasing rate, okay, of the situation. And because it's decreasing, I'm putting the negative, okay. And then you have that it's going to be the integral from 0 to 5. Why 5? Because that's the temperature that I want to estimate, okay. So you have 6e to the power of negative 0.1 T dt. So what are you going to do here? Well, pretty much I'm going to plug this in the calculator, okay. So you have that this is going to be 95 minus some kind of number, okay. So let's plug that in your calculator, okay. So in your calculator here, you go to menu again, you would go to calculus and you would find the integral, and the integral you want it from 0 to 5, and then you have 6 times, then you have an e, okay, to the power of negative point, what was it, not 0, I put that 0, no, 1 times x, okay, because I always work with x's, and then x, okay. So you click and you have that value. Pretty much what we can do is the 95 minus the value that we have over here, okay. So you know that the pizza's temperature now it's going to be 71.391 degrees Celsius, okay. So we have that it was 23.608 ... So what's your conclusion here? The temperature of the pizza, okay, the temperature, okay, of the pizza, okay, when T equals 5 minutes is approximately, okay, what's that, 71.3918 degrees Celsius, okay. And that's pretty much the answer for this problem, okay. I hope that you find this video helpful. Bye.